Number 22. The height of a plant in centimeters is modeled as a function of time in days. Consider this graph of the function. Okay, so this looks like a quadratic function, right? This looks like parabolic. It says enter the average rate of change for the height of the plant measured as centimeters per day between day 0 and day 20. So there's a key word here, average, and then rate of change. So rate of change we've also called growth rate, and we've also called slope. Okay, and then average, what they're asking us here really is, even though this is curved, they're asking us if this were a straight line. So if I put a straight line between these two endpoints, which it's pretty close to straight, but if I put a straight line between these two endpoints, what would the slope of this line be? The slope would be the average rate of change. So if I find my rise and my run, well, my run is 20 days. My rise is, I'm going to have to kind of estimate it. So here's 20, and I'm gone over here. This is 40, this is 50. I'm going to estimate that that's 42 centimeters. And this I'm going to estimate is, let's say, 17 centimeters. So this rise from 17 to 42 would be 25 centimeters over 20 days. So the average rate of change, rise over run, is equal to 25 over 20. I could put this in as a fraction in my grid. I could put it in as a decimal. I'm going to say that as centimeters per day. So just to show you how you would make a fraction, I'll do this as a fraction. This is also as a decimal. This is 1.25. So you could actually enter this either way. I'm going to enter it as a fraction just so you see how to use the grid for making fractions. 25 over 20. So I'm going to grid that in. So I can just use that fraction bar there. The other option would be to grid it in as 1.25.